नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुरिशेट्टी, फैकल्टी ऑफ माइक्रो प्रोसेस। मैं आप सब लोग को स्वागत कर रहा हूं हमारा माइक्रो प्रोसेस एंड पीएलसी सेशन के ऊपर। ये सेशन इंस्ट्रूमेंटेशन बच्चों के लिए है जो लोग इंस्ट्रूमेंटेशन गेट 2026 लिख रहे हो एंड जो लोग गेट ईसी में ऑप्शन 1 एंड पेपर 2 इंस्ट्रूमेंटेशन लिख रहे हो, उन सब लोगों के लिए ये पेपर यूजफुल होगा। सो यहाँ से हम माइक्रो प्रोसेस का कल ने कुछ 8085 के ऊपर कुछ क्वेश्चन डिस्कस किया था। सो जल्दी से जल्दी ज्वाइन करो बेटा। जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए, ऑडियो वीडियो सब कुछ क्लियर या नहीं। अगर ऑडियो वीडियो सब कुछ क्लियर है तो मैं फटाफट स्टार्ट करूंगा। सो लेट अस मूव फॉर द नेक्स्ट। So see here, this was my Telegram ID. So you can join in the Telegram ID so that we can solve some discussion on the questions. Okay. So now let us move for some questions on 8086. Okay. So let us discuss 8086 topic. So in the last class we have covered 8085 related. So today we'll cover the 8086 features. So if you see the comparatively 8085 and 8086, बच्चों के लिए ये पता होना है क्या डिफरेंस रहता है इसके दोनों के बीच में। Okay, so you should understand what can be the difference. So let me write 8085 and 8086. Okay, so if you see the fundamental differences between these two, in 8085 we're having 8 data lines, whereas here we're having the 16 data lines. In 8085 we're having 16 address lines, here we're having the 20 address lines. So key points, please note down. 20 address lines. Okay, so here the memory accessible here is 2 power 16, that is 64 KB memory accessible. Okay, but here it is 2 power 20, so that is 1 megabyte memory accessible. 1 megabyte of memory. So now if you see the range here and the range here, so the range here is 000H to FFFH, and here the range is 1 2 3 4 5H to FFFH. Okay, so these are the key points. Next, the flags here are just 5 flags we are having. So first let us go for the registers. The registers are A, B, C, D, E, H, L, and stack pointer and program counter and flag register. But if we see the 8086, here we are having, in 8086 what we are having here. Okay, in 8086 we are having AX, BX, CX, DX. Okay, so these are the registers. So please make a note of these points. And in addition to that, we are having source index, destination index, base pointer, stack pointer. In the place of program counter, we are having instruction pointer. AX, BX, CX, DX, SI, DI, BP, SP, IP. Okay, chalo. Next, in addition to this, we are having code segment, data segment, stack segment, extra segment. And we are having the flag register. And the flags available here are, what are the flags available here? Carry flag, parity flag, auxiliary flag, zero flag, sign flag. But here we're having totally 9 flags. 9 flags. So they are split into many categories like this. 6 status flags, 3 control flags. So what are the status flags? Good morning. Yes. What are the status flags? If you see, carry flag, parity flag, sign flag, overflow flag, direction flag, interrupt flag, trap flag. Okay, so these are the flags. Please make a note of this list once. Complete list of the differences. Good morning. नोट कर दिया? चलो. So now if you see some interesting questions, answer this question, make it fast. Which instruction in 8085 processor can set a flag? Which instruction in 8085 processor? If you see these instructions, So move B comma C, it is a data transfer instruction. So in data transfer instruction, there is no question of flag. Next, jump if not 0. If 0 flag is set, if 0 flag is equal to 0, then jump. Then jump to 2100. So this is also wrong. He is asking which instructions will set the flag. But this instruction is if flag is reset, then it will go there. Next, store accumulator means the contents of the accumulator are traveling to a memory location like this. So this is the memory location. So 2000H is the memory location. So the contents will go here. Next, add B. The contents of the B will be added to the C. Sorry, one of the register is A. So the contents of the B will be added to the contents of the A, and the result is stored into the A. Contents of the B will be added to the contents of the A, and the result will be stored into the A. So here there is a possibility of carry flag. So option D is the right answer. So let us go for the next question. Answer this question, make it fast. Yes, good morning. इसका आंसर क्या होगा? ऑप्शन डी होगा. सो रिजल्ट्स लीडर बोर्ड पर कोई नहीं आ रहे, पोल आ रहे हैं आपको, एक बार चेक करो. So see here what is going to happen. Move B comma C means contents of the B will be traveled to the B. So this will not make any accumulator. So XOR A means A XOR with A. Then the answer will be 0 na. So option D is the right answer. Okay, so let us go for the next question. Answer this question. I am giving 60 seconds of time. Are you getting the poll? Yeah. Try to answer. Let the content of the memory location 3501 is 72H. So this content here is 72H. Now consider the following program with the 8085 microprocessor LDA, CMA, STA halt. The content of the memory location 3502H after the execution of the program will be dash. After the execution of the program will be dash. Do it. And the content of the memory location 3501 which is equal to 72H. So this is, let us see the content here. The content of this 3501 is 72. Let the content of the memory location 3501H is 72H. Now consider the following program with the 8085 microprocessor LDA 3501H. So this accumulator is equal to 72H. So that means it will be 0 111 0 0 1 0. Next, complement accumulator. So A dash, if you complement, so this is 1 0 0 1 1 0 1. Next, STA 3502. Now this particular 3502, this content of the accumulator has to come here. So the content of the accumulator will be what now? This is 8 and this is 1248. 8 10 B11 C12 D13. 8 10 B11 C12 D13. So this is 8D. So 8D will come here. So question asked is the content of the memory location 3500H after the execution of the program will be 8DH. Option C is the right answer. कोई नहीं है लीडर बोर्ड पर? क्या आपको पोल नहीं आ रहा है क्या? Are you not getting the poll? So please participate in the poll. Please participate in the poll. Please participate in the poll. Okay, so let us go for another question. Answer this question. I'm giving 30 seconds time. Please participate in the poll. What addressing mode is used in the instruction written? So that is a implicit direct addressing mode. We are going to get example like LDA. So what is the direct addressing mode? So the direct addressing mode is LDA 2000H. So immediate addressing mode, move immediate, some B comma 45. Next, implicit addressing mode, complement accumulator, like STC, return. So these all are implicit addressing modes. Register indirects, so move A comma M. This is a register indirect addressing mode. So the right answer here is implicit. Option C is the right answer. Nobody has given leaderboard. Chalo, let us go for another question. Answer this question. Do it. The zero flag of the 8085 microprocessor is to set keeping the content of the accumulator unchanged. Which instruction is to be used? So compare instruction. Suppose compare instruction will compare with compare, but A will be zero flag will be set. Compare instruction is similar to subtraction instruction. Compare instruction is similar to subtraction instruction at Patel. So what is asking which instruction to be used? Keep the content of the accumulator unchanged. Zero flag has to set na. So compare instruction will be using for that. So option D is right answer. क्या आपको लीडर बोर्ड नहीं आ रहा है क्या? Are you not getting the leaderboard? Okay. So let us go for the next question. So simple questions, try to answer. Good morning, Rashmi. Yes. What is the answer here? The register which holds address of the next instruction to be executed, the program counter. So option B. I think everybody has given now. Okay. Very good. 28. So let us go. Accumulator will accumulate the result. Accumulator will be accumulating the result. Next, program counter points the address of the next instruction. Address of next instruction to be executed. Stack pointer represents the top of the stack. Top of stack. Instruction register holds the present instruction. Holds the instruction. Holds the instruction. Okay. So let us go for the next question. Try to answer this question. 11 students are live. Try to answer, make it fast. चलो, how to answer this question? If the memory size is 256 into 1 bits, so this is 256 into 1 bit. That means this you can write like this, 2 power 8 cross 1. So where this 8 represents something and where this m represents something. So this is a n, that is equal to 8, and this is equal to m, that is equal to 1. How many number of chips are required? How many number of that chips are required to make it 1 KB? 1 kilobyte. 1 kilobyte means we can write 2 power 10 cross 8. So that means in this situation, the number of address lines and number of data lines, if you check, so this is n is equal to 10, this m is equal to 8. So what is the n now? So 2 power 8 into 1, how many such n are required to make 2 power 10 into 8? So n is equal to 2 power 10 cross 8 divided by 2 power 8 cross 1. Okay, so that becomes 2 power 10 by 2 power 8, that means 2 power 2. This is 2 power 3. So 2 power 5. So 2 power 5, that means 32 chips are required. Why? Because this is 2 power 10, it is cut na. 2 power 8 cut. So 2 power 2 will be there, 2 power 3, 2 power 5 means 32 chips are required. So the right answer for this question here is 32 chips. Option A is the right answer. What happened here? Nobody has given. क्या हो गया? Answer नहीं है आपको. So this is a standard way of doing. The chip size, how many number of such chips are required to get this? So n is equal to this by this. So 2 power 10 by 2 power 8, 2 power 2 into 2 power 3, 2 power 5. So 32 chips are required. Okay. So let us go for the next question. With practice, please answer this question. Make it fast. So how to make it? So see here, it's a very good question. A memory systems of size 16 kilobytes is required. How many? 16 kilobytes. 16 kilobytes are required. A memory systems of size 16 kilobytes is required to design using memory chips which have 12 address lines, 4 data lines. So what is the size of the chip? So if you see the size of the chip, so this is 12 address lines and 4 data lines, 1 chip size. So number of address lines and number of data lines. So number of address lines is this, n is equal to 12 and m is equal to 4. A memory system of size 16 kilobytes is required. So how much size is required? So 16 KB size, 16 kilobytes. A memory system of size 16 kilobytes is required to be designed using memory chips which have 12 address lines and 4 data lines each. The number of such chips. So number of such chips n is equal to 16 kilobytes divided by 2 power 12 cross 4. So 16 means we can write 2 power 4. This is 2 power 10. Byte means 8. So this is 2 power 12 and this is 4. So now what happens? This total 2 power 3. So 4 plus 10, 14 plus 3, 2 power 17. So 2 power 17 minus 2 power 2, 2 power 14. So 2 power 14 means 2 power 3, that becomes 8. So the right answer is option C. Kya yaar? Nobody is giving the answer. At least some type karo na. Are you getting the poll or not? Excuse me, different people are there. Are you getting the poll or not? Yeah. Chalo, let us go for the next question. Answer this question. Very simple questions for practice. Eight kilobytes memory. So 8 KB means this is 2 power 3, 2 power 10 into 8. So this is the data lines. So 8 KB. So 13 cross 8. So n is equal to 13, m is equal to 8. N represents the address lines, m represents the data lines. So I will hut the little board hata kar tu maine. Nobody is attempting. Okay. Yeah. Answer this question. Poll is coming or not? Tell me, inform. Poll. Okay. Chalo, I will give the poll now. So see here. In a 8085 microprocessor, by system, the active low chip select signal is generated by passing address A15, A10 through 6 inputs NAND gate. So there is NAND gate. So this is the NAND gate. Okay. So what are the inputs I am giving? A15, A14, A13, A12, A11, A10. So these are the inputs. A10. So he's telling that these are the inputs. A10, A11, A12, A13, A14, and A15. Okay, so this is an AND gate, and this output is given to chip select signal. Okay, in a 8085 microprocessor system, the active low chip select signal. So CS bar must be 0 here. It must be 0 means these all must be 1 inside. Okay. For selecting the address range CC002 CCFF, sorry, CFFF. So it is having 16 address lanes. Let me write that 16 address lanes here. A0, A1, A2, A3. Next, A4, A5, A6, A7. Next, A8, A9, A10, A11. Next, A12, A13, A14, A15. Okay, so he is asking address range CC00. So that means this should be C. C means what is C? A10, B11, C12. So that means, so this is 11, 0, 11, 0, and these are 0, 0, 0, 0, 0, 0. So this is 1, 1, 1, 1, 1, 1, and this will be 1, 1, 1, 1, 1, 1, 0. So the range is CC 002 CFFF. So it should come like that, means he's asking the configuration of A15 to A10. So if you see the A15 to A10, so this is A15 to A10. A15 to A10. If you check A15 to A10, A15 to A10. So what I'm getting? So this is 1, 1. Now you check what is configuration. A15, A14 must be 1. A13, A12 must be 0. A10, A11 must be 1. Yes or not? So that is the, if you want to get that address. Okay. That means what? A12 and A13 must be zeros. That means A12, A13 must be zeros in the initial. So they 0, 0 here. So they'll come 1, 1. Okay. So 1, 1, 0, 1, 1, 1, 1, 0, 1, 1. Okay. So now what is the configuration? See, A15 must be 1, A14 must be 1, A13 must be 0, A12 must be 0, A11, A10 must be like this. So option A is the right answer. Option A is the right answer. क्या यार लीडर बोर्ड कुछ रेस्पॉन्ड दीजिए यार, लीडर बोर्ड आ रहे नहीं आ रहे, एटलीस्ट दैट यू टेल ना. सी मैंने पुष्प नहीं आ रहे. ओके ओके. Okay. So what is the answer? Option A is the right answer. Chalo. Now answer this question. Make it fast. Okay, now let us see here what is going to happen. Let us see here. So first of all, ALE stands for address latch enable. So this goes to 4. So this goes to 4. PSW means program status word. This goes to 5. CMA means complement accumulator. So this goes to 7. Next, RLC means rotate accumulator left without carry. So this is 8085. So S goes to 1. P goes to 4. P goes to 4, S goes to 1. So option C is the right answer. So option C is the right answer. I think next onwards you'll get the leaderboard. So let us see this one. Yeah, answer this question. So I'm giving a leaderboard. 120 seconds ka time de raha hu. So try to answer this programming question. So see this particular topic. LXI B 2070. That means BC register will become 2070. So BC register will have 2070. Okay. Next move immediate A. A is equal to 8F. Next move immediate C. C is equal to 68. Subtract C. That means C has to be subtracted from the A. So first we have to take C complement 0 1 0 0. Sorry 0. So this is 0 1 1 0. 8 means 1 0 0 0. Okay. So now if you take the ones complement of this 1 0 0 1 0 1 1 1. Now add plus 1 to this 2's complement. So 1 plus 1 1 0, 1 plus 1 1 0 1. So this is 1 0 0 1. Okay. So now this is add A to this. A is equal to 8F. That means 1 0 0 0 1 1 1 1. So 0 plus 1 1 1 1 1 plus 1 1 0 1 plus 1 1 0 1 0 1 plus 1 1 0. So what we are getting here? After that you are making AND immediate 0f 0 0 0 1 1 1. So now this will be 1, this will be 1, this will be 1, 0 0 0 0 0. So I am getting 0 7. Next STXB. So this value of accumulator 0 7 has to move to BC address. The BC address is here, that is 2070H. So this value is moved to this 07H. Okay, so the right answer here is this. Option B is the right answer. 100%. Excellent. Oh, Sat. Excellent. Mayuri. Okay, nice. Nice, nice. Now you are getting the pole, right? Okay, chalo. Now let us go for the next question. Answer this question. I am giving the pole for you. B R है. Okay. Chalo, let us see here. Move immediate A comma A7. So A is equal to A7. That means 1 0 1 0. So 0 1 1 1. Next, RA with A. So again you are taking A. That is 1 0 1 0. So 0 1 1 1. So when you perform the OR operation, so what I am going to get 1. This also 1. This also 1. This will be 0. Same na? 1 0 1. Okay. Now rotate left without carry. So there is no carry set na. So carry flag is reset actually. So carry flag will be 0 here. So 1 0 1 0. So 0 1 1 1. So we have to rotate. So this should be 1 here. So this should be 1 here, this should be 1 here, this should be 0, 0, 1, 0, this is 1. So now without carry, this MSB will be coming here. So LSB will jump to MSB, MSB will jump to carry, and MSB will come back to LSB. So this answer will be 4F, na? So finally the answer is 4F. So option B is the right answer. क्या हो गया यार? Nobody has given the right answer. चलो, option B is the right answer. All of you understood? Question समझ में आपको? Yes, Pushpa, Mayuri, is it clear? Option B is the right answer. So let us go for the next question. Answer this question. थोड़ा सा रेस्पॉन्ड दीजिए भाई, है तो है, नहीं तो नहीं. So see here, move immediate A comma 45. So A is equal to 45. So 0, 1, 0, 0, 0, 1, 0, 1. B comma A. So B is equal to A, that is 0, 1, 0, 0. B is equal to 45. Okay, that's fine. Let us write like this. Move A comma 45, B comma 45. Next STC, the carry flag is equal to 1. Next to CMC, carry flag is equal to 0. Rotate accumulator to right. So right side na. So first let us take accumulator. Accumulator is equal to 0, 1, 0, 0, 0, 1, 0, 1. So rotate accumulator to the right. So this is the carry flag. So carry flag he has made 0. So in instruction there is no carry, so you have to include the carry. So rotate accumulator means what? MSB has to be shifted to LSB. LSB has to be shifted to carry. So carry will come to MSB. So how it will happen? So this is 0, 1, 0, 0, 0, 1, 0, 1, and this is this. So answer is coming relatively XR ये कर रहे हैं. See, one second. A is equal to 45, so rotation means 0, 1, 0, 0, 1, 0, 1 will come here. C carry will be coming here. So the answer is 22 here. So this is a carry. It's a carry. So 2, 2. So next, after that XRA with B. So this is A na. Next we are going for with B. So what is the B? B is equal to 45. 0, 1, 0, 0, 0, 1, 0, 1. So now we have to perform the XOR operation. So this will be 1. Sorry, XOR means what? When both are same, output will be 0. So 1, 1, 1, 0, 0, 1, 1, 0. The right answer is coming as 67 na? So the right answer is coming now. So this is the answer. So A will be coming as 67. So the right option here is 67. Option C is the right answer. Option C. Nobody. Option B दे रहे हैं, लेकिन B गलत है रे. Option C is the right answer. Option C is the right answer. एक बार check करो. Yes, I will start measurements soon. 67 set करो. Okay. So very interesting instructions. So try to understand these instructions. Very very interesting instructions. किसका रंग है? किसका रंग है? डी और बी. गलत आंसर है. डी और बी आ रहे हैं ना. विच इज रॉन्ग? डी और बी. मेरा गलत है. एक बार देखो. मूव ए कामा 45 आ रहा है. नेक्स्ट मूव बी कामा ए आ रहा है 45. STC means carry flag is 1. CMC means carry flag is 0. So accumulator I am taking as 45. 0 1 0 0 0 1 0 1. So you have to rotate to the right. Carry flag is equal to 0. So in the instruction carry flag is not there means you have to include the carry in the rotation. RAR का मतलब क्या है? RAR का मतलब है कि RAR का what is the मतलब of what is the meaning of RAR? So you have to rotate accumulator to right side including carry. So that's what I am telling. Right side shift करो. MSB to LSB shift करो. LSB to carry shift करो. Carry फिर वापस MSB के प्लेस में आ जाना है. So क्या होगा? अभी इधर ब्लॉक लगाओ. So this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here, this 0 will come here. This 1 will come here, this 0 will come here, this 1 will go to the carry and the carry content 0 will come here perfectly. So this is 67. So A is equal to 22. उसके बाद मैंने B से XR कर दिया. B से XR operation. What is XR operation? 0 XR with 1, 1 XR with 0, 0 XR with 1, 0 XR with 0, 0 XR with 0, 1 like this. So I'm going to get 67. So the right answer is option C is the right answer. Option C is the right answer ना. अरे बपन बैरंगी क्या बोल रहे आप? क्या बोल रहे हैं यार? चलो, let us go for the next question. Many good questions are there. आंसर दिस क्वेश्चन। हाँ चला, ऐसा कुछ रेस्पॉन्स दीजिए। वेरी इजी क्वेश्चन ना, इसके लिए कुछ टाइम की रिक्वायरमेंट ही नहीं है। 30 seconds. Everybody can answer this question, I think. When a program is being executed in the 8085 microprocessor, its program counter contains dot. Very simple question. Chalo. When a program is being executed in the 8085 microprocessor, its program counter contains the number of instructions. No, the memory address of the instruction is being currently executed. The memory address of the instruction that is to be executed next. So option D. इसको भी गलत कर दिया आपने, लीडर बोर्ड पर कोई नहीं आ रहा, ऑप्शन बी ना। चलो लेट अस गो फॉर द नेक्स्ट क्वेश्चन। Answer this question. In a microcomputer, why the wait states are introduced? This also repeatedly asked question. Very repeatedly asked question. See, wait states are introduced generally what? So if you have a peripheral, this is the external peripheral, this is the other peripheral. So now this is the external peripheral. So this is a microprocessor. So microprocessor gives something to that. Microprocessor has given something to that. But this is a very fast device. This is a very slow device. Na? Nobody can match the speed of the master. Then microprocessor has to send the next cycle. But without confirming this previous data has been reached or not, how the microprocessor can reply? Then microprocessor only has to compromise. A higher only can compromise, not the lower. Always remember, a master only has to compromise. A slave cannot compromise. So that's why it will introduce a wait states. I will wait. Microprocessor will wait until that slow device is ready. Okay. So interface slow peripherals. Option D is the right answer. Okay. Let us go for the next question. Answer this. LXI. So what is this? This is HL 3600. Move A comma M. So there is a memory location like this. So this is our 3600 memory location. In this, whatever the content is there, that has to come to accumulator. So that is the meaning. Halt. The move instruction involves what? Indirect addressing, immediate addressing, implicit addressing, indirect addressing. Why? Because direct means it will be like this, LDA 3600. Implicit addressing means implicit means halt. Okay, immediate addressing means move immediate. Okay, ma? So that's it. Indirect addressing. Option A is the right answer. Okay, I think leaderboard मैंने नहीं दिया, छोड़ दो, बच्चे नहीं देख रहे हैं, क्या पर्पस है उसमें. Answer this question. Make it fast. Move immediate A comma 78. So this A is equal to 78. So this is 0 1 1 8 means 1000. RLC. Okay, rotate left to carry. So carry flag is equal to here. So this is 0 1 1 100. So if you are rotating this now, so you'll get 0 0 0 1 1 1 1 0. Okay, so it's a LSB will come here. So LSB will go to MSB, MSB will go to the carry, and the MSB will come back to the LSB. Okay, so is the carry generated? No. If the carry is generated, will go to 7000H. What is the meaning of this instruction? Jump if carry, go to the 7000. So if carry is not generated, what happens? This is 6003, this is 6004 address, this is 6005 address, this is the 6006 address. So answer is option B. Option B is the right answer. Very good question actually. Yes, Sai Kiran. Option B is the right answer. Why? Because carry is not set. 6003, 6004, 6005. See, this is memory location. 6003 la JC will be there. 6004 la lower 00 will be there. 6005 la JC will be there. Next instruction starts here. So if carry is set, it could have gone. If carry is set, it could have gone to 7th one. But carry is not set, na. Check it. The 0 is coming here. So carry will not set. So answer is option B is the right answer. Chalo. Answer this question. Make it fast. How many mission cycles will the execution of the instruction STA? So first of all, you have to understand what is STA 2000H. So this STA 2000H will be present in a memory location first of all. So this comes STA, this is 00, this is 2. So this is STA, this is 00, this is 20. Okay, so first mission cycle is you have to fetch this. That is what we call as opcode fetch mission cycle. Second one is this one, operand read. You have to take that. Okay, so operand read. operand 1 read. Next this one, operand 2 read. Operand 2 read. And when you decode this instruction, there is a content of the accumulator has to be written into, there is a content called accumulator. In the accumulator, whatever the content is there, that has to go to 2000H memory location. So that means A has to be written to 2000, that is memory write. So actually speaking, opcode fetch is also a memory read. Operand 1 read also memory read. Operand 2 read also memory read. And this is memory write. So total how many now? This will take as 4 T states. This is 3T. This is 3T. This is so 3 plus 3, 6 plus 3, 9 plus 4, 13 T states. So number of T states are 13. Number of T states are 13. But the number of machine cycles, if you see, how many machine cycles are there? 1, 2, 3, 4 machine cycles. 4 machine cycles. So the right answer is very good question actually. Option B is the right answer. Option B is the right answer, Sai Kiran. Okay. Okay. Chalo. Let us go for the next question. Answer this question. Make it fast. What is the answer? See here. In 8085 microprocessor, the contents of the register SP, So the SP is given as what? 5FF 8H. B is equal 34, C is equal to 7F. So B is 34, C is 7F. Before the execution of the instruction, push B. So when I say push B, what happens? So what is the operation of the push B? So this is our stack pointer. So this stack pointer is equal to 5FF8. So when I say push B, the stack pointer has to be decremented by twice. So it will become as 5FF7, 5FF6. So these are the latest top of the stack. Okay, and push B means C, lower will come to lower, C will come here, B will come here. So this is 7F and this is 34. Okay, so after the execution of the instruction, what is asking the value of SP? The value of SP will be 5FF6. The content of the SP also is asking. So 7F is the content. So 5FF6 and this. How many have correctly answered? Option C is the right answer. Option C is the right answer for this particular question. Okay, so badhiya, chalo. So we have discussed very different categories of questions. Okay. Answer this question. It was a JTO 2006 का सवाल है. Try to answer. What they're asking, a 3-byte instruction is executed in the 8085 microprocessor by following steps. Stack point is decremented by twice means definitely it should be push or call. See, stack point is decremented by twice. So that means this was the top of the stack. So the stack pointer was decremented by twice. So this is a new top of the stack. Okay, SP minus 1, SP minus 2. Okay. So the corresponding next is telling that PC is changed. PC is changed means you are going to some other. So you are from here you are jumping to 008. That means the call instruction. Option C is the right answer. Option C is the right answer. Okay. So these are some quality questions of microprocessor. If anybody can answer some interfacing questions also, yesterday we have discussed. So can you answer this question? Make it fast. Try to answer here. The figure shows an interfacing circuit for the 8085 microprocessor to read 8-bit data. Then the appropriate instruction for reading the data is dash. First of all, you have to see how many address lines are there. So it's a very typical question. Here A8 to A15 you are not using. You are using only A0 to A3 to A7. A0, A1, A2 are here. So you have to choose Y2. So this has to be selected. This has to be selected means this A0, A1, A2 must be 0, 1, 0. Okay. Why? Because it is y naught key 0 0 1. So if it is 0 0 0, y naught will be selected. Suppose if it is 0 0 1, y1 will be selected. 0 1 0, y2 will be selected. Okay, y2 will be selected. Okay, so that's fine. Next, what about A3, A4, A5, 7? See here, A3, A4, A5, A6, A7. Okay, so this is an AND gate. It must be 0 here. That means all must be ones. That means what? F A. So the right answer is IN. Why? Because it is a 8-bit na. So, and one more, sorry, one second. This is OR gate, OR gate. So OR gate, sorry, NOR gate. This is NOR gate. So NOR gate, and this output is 1 here. E3 is equal to 1. I think logic high. So IO by M bar, read bar. So what is a NOR gate truth table? So read bar is that IO by M bar is another input, and the output is this 0 0 0 1 1 0 1 1. Think over it. If you are taking OR gate, any one of the 1 is equal to 1, output will be 1. This is for the OR gate. But for NOR gate, quite opposite. So this will be 1, this will be 0, this will be 0, this will be 0. That means both are 0 0. IO by M bar is equal to 0. So IO by M bar is equal to 0. Very interesting. IO by M bar is equal to 0. That means it's a memory related operation. So memory related operation means you cannot go for IN. So you have to go for this LDA. Very superb question here. LDA and FA is there. So another one is you can take A8 to A15 are unused. So you can take that. LDA is the right answer. It's a very good question actually. Very, very good question. Okay. Chalo. Enough for today. Last question. Any doubts in the last question? Done. Actually here itself question is done here. Why? Because it's a NOR gate kada. NOR gate output should be 1 here. When both are 0 0, output will be 1. So read bar is equal to 0, IO by M bar is equal to 0 means it's a memory related operation. Memory read means from the memory you are reading. So the instruction matches is LDA. That's it. No need of thinking about the address and all those things. So right answer is this question. Okay. So enough for today. So very good questions we have discussed. So next sessions we will start the instrumentation core subjects. So जितने लोग possible है live में आने की कोशिश करो. Okay. So we'll discuss that instrumentation questions. Okay. चलो.